So just be a jerk all the time and be happy. Just kidding. That's not the right way to be. All right. 5. How many grams of bromine reacted? Who's got it? Paige, thanks for volunteering. The worst case scenario is you're wrong. I mean, I'm sure there's other people that are wrong in here. It's okay. 100 for what? A bromine. Let's see. Close. Want help? Sure. Okay. So here's your reaction. Okay. So before and then after, right? So here's the before. Here's the after. So before, this is the compound. You had no idea that's the compound, but when aluminum bromine react, this is what they make. Now let's real quick, Liz, restate the law of conservation of mass. Right, mass cannot be created or destroyed. That's why I did that demo yesterday. It was off by 0.1 because the scale is a little bit finicky. But the point of the demo, it was basically the same mass, right? So if I have 100 grams of reactants and all of it reacts, I will have 100 grams of products, right? So in chemistry, like this is not a chemical reaction, but the mass of this right now is exactly the same after I bend that little coin, or whatever you want to call it, and then it turns white and gives off heat. It'll have the same mass. Okay, this would actually be a good example too. I can mass it now, do it, and then mass it again. Maybe we will, just to prove it to ourselves. The point is, the mass of these will always equal the mass of your products, but this question's harder because not all of your reactant react. So if you have 100 grams of these two and only 90 grams react, then this will only have a mass of 90 grams. It can't have a mass of something it doesn't have yet. So if not all of this reacts, then the mass will not equal all of it. It'll only equal what actually reacts. So if we start with, what is this, 10.3? Yeah, 10.3 grams here and 100 grams here, right? Is that what we're starting with? Okay, after the reaction, okay, there is 8.3 grams of this, 0 grams of that. So you take aluminum, you take bromine, they come together, it's called synthesis, they make a product. All of the aluminum, all of this is right here. All of it. So beforehand we have 0 of the compound. After these react, we know we have at least 10.3 because that's from the aluminum. All of the aluminum is right here. So that's from the Al. Now, what part of the final mass is bromine? Not all 100. I think Paige is with me now because 8.3 grams of this did not react. So Paige, how many grams did react? Yeah, you would subtract 100 minus 8.3, which is 91.7, right? Right? Yes? Ben, you with me? Do you agree with me?
There's 8.5 grams of bromine left over.
It's not 8.3?
Yeah, it's 8.5.
I didn't want to be that guy.
No, you gotta be that guy. So 91.5?
Yeah.
Okay, so 91.5 grams of BR is in the product. So out of the 100 that we started with, only 91.5 reacted. That's really common in chemistry. Not all of your reactants react. It's hard to get into why right now, but that's really common. So this is not going to be the same that's in the compound. It's the difference. So 91.5 plus 10.3, that's the total mass of the compound. But to answer the question, it's 91.5. So the first part is 91.5. How many grams of the compound? So 10.3 plus 91.5, which is 101.8. 101.8. That's the total mass of the compound. Questions? Okay. Where are we? 6. From laboratory process designed to separate water into hydrogen and oxygen. That's that contraption over there, electrolysis. Student collected 10 grams of hydrogen. All right, let's write the reaction out here. So if we have H2O yields H2 plus O2, all right, it says student collected 10 grams of hydrogen, 10.0 grams of hydrogen gas, and 79.4 grams of oxygen. How much water was originally? So what's the mass of the water? Conservation of mass says you can't create or destroy mass. So if you know the mass of the products, they will always equal the mass of the reactants, and then vice versa. Okay? As long as you know one or the other for sure, you can figure out the other one. It has to be the same number. So 10 plus 79.4 is 89.4. That's the answer to this question. 10 grams turned into hydrogen gas, and then 79.4 turned into oxygen. Questions? Okay. Just to really kind of pound this home here, all right, if you have something that kind of looks like a balanced type of scale type thing, your reactants and your products should always be equal, right? If you think of it in terms of that, so kind of like scales, right? You're not going to be dipping down one side or the other, just a another way to kind of think about it, all right? This may be, you guys may get it, and I may be talking to the air here. I just really want you to understand, because on a Regents, it gets confusing. You got a lot of stuff in your brain. You just got to remember the mass of products equal mass of reactants, and vice versa. That first question's a little confusing because not all of them reacted, right? So you just got to keep track of that. All right, 7. Sodium, and what do we have? Chlorine. All right. So we have sodium and chlorine. Na plus Cl2 yields NaCl. All right, now it says 15.6 grams of sodium. So 15.6 grams. And this is always a good way to do these problems. If they don't give you the formula, the equation, write it down. Okay? Sodium plus chlorine yields salt. And again, you guys should know this at this point, right? Cl2. We're going to talk more about that maybe today or next week for sure. All right, now it says reaction is complete. Student obtains 39.7 grams. All right, so 39.7 grams here of NaCl. All right. How many grams of chlorine gas reacted? How many grams of sodium reacted? All right, I'm going to answer the second question first. All of the sodium reacted. So this is a little bit of an advanced question, so pay attention here. Look at me. In chemistry, there's always 2 reactants. Sometimes there's one. If there's 2 reactants, one of them is called the limiting, one of them is called excess. This is not Regents level, but I use it to explain this question. Okay? And it is something that's good for you to hear. They said this was excess, didn't they? They said it was excess? Okay. What does excess mean to you guys? Extra, too much. Okay? Excess, it means too much. Okay? So to make this really simple, I know there's a 2 there, but I'm going to ignore the 2 for a second. Let's say red is sodium, chlorine is yellow. If I want to make salt, I need 1 Na and 1 Cl. Because this is excess, let's say you have 6 of these, but only 1 of those. If I want to make NaCl, I can only use 1 of these and 1 of these, and that makes NaCl. Oops, makes NaCl. Do I have any Na left? No. So Na is called limiting because it is limited supply. So this gets completely reacted. So all of this goes here. So the answer is 15.6. All of the sodium reacts. So there's essentially none of that left. But I have excess, right, extra Cl left over. So when they say excess, that's what they mean. Okay, so all of the sodium reacts. And this is really typical in chemical equations, chemical reactions. If I was to light a match in this room, it would burn. What's the excess reactant? Oxygen. Who said that? Very good. It's not the match. Will the match eventually go out? Yeah, so the match is one reactant, and that burns up. But the air, the oxygen in this room doesn't burn up. There's plenty of it. So there's going to be oxygen left over. I'm just trying to get you to understand the concept here. All right? So all the sodium reacts. some Cl's left over. How do we know, right? It says, first question, how many grams of chlorine reacted? So if we know 15.6 grams is the sodium, right? We subtract these numbers, 0.1 plus 39 minus 15, 24, right? 24 grams of Cl reactant. Conservation of mass. The mass of your reactants that actually react are going to equal the mass of the product. So 15.6 of this mass is Na, the rest of it is Cl. Again, these are a little confusing. That's why I had you raise your hand. You thought it was hard or a little hard, because this is not actually reagents. It's harder. I try and do this all year. I try and give you harder questions, because when you get to the easy reagents question, they're going to tell you the amount of both. All you do is add them. Or they're going to tell you one, tell you the other. You just subtract like this. But all of it's going to react. It's not going to have excess, eliminate, and all that stuff. That's not reagents. All right, 8. Yeah, 8. All right, here we go. Magnesium and oxygen this time. Okay, magnesium and oxygen. We're making magnesium oxide. All right, right. Okay, 10 grams of magnesium. Yeah, here we go. This is the reagents question. 10 grams of magnesium forms 16.6 grams of magnesium oxide. How many grams of oxygen reacted? How would we figure that out? Kara, what do we do? Right. This plus this equals this, right? Look at it this way, like a math problem. Very simple. This plus this equals that. Conservation of mass. Mass of reactants equals mass of product. Subtract. 6.6 grams is the answer for oxygen. I don't really give a lot of notes on this because we do this homework, so I hope you guys are picking it up. You got to ask me questions if you're not. I might give you one more in the notes, but then we're going to move on. All right. Okay, where are we? 79. Over here. All right, I'm going to go a little bit faster here. I'm just going to read answers. 13A is 58.44 grams of sodium. 13A, 58.44 grams of sodium. 13B, 66.7 grams of Y. 14, because composition does not change during a physical change, the appearance of a substance does not change. I think we already did this, or something similar. The appearance does change. This ice is going to look very different as liquid water, right? Once it all melts. So it does look different. That doesn't mean the composition changed. All right, and 98, number 3. Well, here, we'll go in order. I don't know why I did that. But 96, go to 96, please. Stay with me. All right, 96, number 83. What are we doing here? Phosphorus combines with hydrogen to form phosphine. In this reaction, 123.9 grams of phosphorus combines with excess, blah, 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 blah. Okay, here we go. I'm going to write this one down. All right, so we have, what is it, phosphorus and hydrogen. Yeah, okay. We got P plus H2 yields PH3. Okay. All right. Now it says we have 123.9 grams of phosphorus. 123.9 grams of phosphorus. Excess hydrogen. So what's excess mean? Means we have too much of this. There's going to be some left over. Produce 129.9. All right, so 129.9 grams of the product, phosphine here. After the reaction, all right, let's do it this way. Okay, so beforehand, right, here's before, here's after. All right, so this is limiting. Why? Because they told me this was excess. We don't know how much we started with, but we know all of this is reactant. Why? Because this is excess. Like I said before, if this is excess, that means this is limiting. So all of this reacts. Okay. Initially, 0. Afterwards, we have 123.9 plus something. Right? So all of this is in the P here. All of it. Okay. It says hydrogen after the reaction, 310 remains. They want to know this, right? They want to know how much, actually they want to know what is the mass of hydrogen that is actually reacted. So, do they give us a final? Oh yeah. So this plus this, right? Here's our P, here's our hydrogen, equals what they told us. 129.9. So they told us this is the mass of the product. I'm telling you, all of this is in the product because this is excess, therefore this is limiting, meaning it reacts completely. So what's that number right there? That's the answer. That's the answer to how much hydrogen reacted. Who's got it? Who did this right? A bunch of you. Emily, what'd you get? 6 grams, right. I mean, I can do the math. I just want you guys to tell me. Okay, so 6 grams. Very good. So what was the original mass of hydrogen? It would be 316. The original mass was 316. Because if 3 10s left over and 6 grams reacted, the starting mass is 316. I don't think it asked that question, does it? Yeah, there you go, it does. Okay. 84. What's 98? Hold on, you don't have to flip. What's number 3 here? Okay, number 3, the answer is law of conservation of mass. It says after 2 elements react to completion in a closed container, the ratio of their masses will be the same before. I tried to show you that yesterday. So, the ratio of their masses, let's not get confused. So, if there's a certain ratio here, it has to be the same ratio here. That's what the law of conservation of mass is. So, the mass of this and the mass of this will be present in the mass of this and this, right? They will be found here. That's what that means. The ratio of P to H will be the same in terms of mass. So anyways, that was the multiple choice question. That was C. The reason I did that first is because number 84, I'm going to have us actually write this in our notes. So take your notes out. You can actually put the books back. I'm just going to talk about this one kind of out loud in our notes, so go ahead and put the books back. After this, I will get back to quizzes. I wanted you to have homework. I don't know if we're going to be able to get to it. I'm sure you'll be upset. If we don't get to what I want to get to, then there won't be none. It's just a worksheet. Very simple. Alright, so in our notes, we wrote down the demo yesterday, right? We had Ki plus AgNO3 yields KNO3 plus AgI. Is that correct? That's the last thing we should have. I wanted to write down the demonstration. Yes, we're good? Yeah? Okay. Alright, so just put this underneath that as far as this is conservation of mass still. So the question in the homework says you have hydrogen and oxygen making water. Alright? So there's a couple, I'm going to kind of teach a bunch of things at once here, and then I'll give back your quizzes. Alright, so it says if you have 100 particles of hydrogen and 100 particles of oxygen, how many particles of water can you form? Will you use all the particles of both? If not, what will remain? So remember, conservation of mass means if this has a mass of 10 grams and this has a mass of 10 grams and all 10 grams and all 10 grams react, we will get 20 grams of this, right? But it's a little bit more confusing with some of these equations. But the law is what it is. So let me say that again. However much of this reacts, that's how much will be present here, right? So again, if we have 10 grams, just watch, don't write. If you have 10 grams of this and 10 grams of this, but only 5 grams of this react, then this will be 15 grams. It won't be 20 because I still have 5 grams of this floating around. It's not reacting. Okay, so that was part of the homework to really pound that home. All right. Who sees a problem with what I wrote on the board? In the term conservation of mass. Jake, you with me?
Yeah.
I'd like you to not lean on your hand just for 5 minutes. Thank you. Let's do the math. What's the mass of 2 hydrogens? You can look over there, or you might already know it. What's the mass of 1 hydrogen? 1 gram. So this is 2 grams, right? You have 2 H's? Okay. What's the mass of 2 oxygens? 32, right? So 15.999 rounds up to 16. So this is 32 grams. Okay. Add up 2 H's and 1 O. It's 18, right? You got 2 H's, so that's 2 plus 16. This is 18 grams. That doesn't work. Breaks the law of conservation of mass. What's 2 plus 32? 34. Is 18 34? No. What's the problem? Let's use the magnets. Okay. Hydrogen is red. Oxygen is yellow. Water looks like Mickey Mouse. The Mickey Mouse molecule. That's not my thing. It's an actual thing that people teach. I can take credit, I suppose. But... All right. What's the problem?
You have excess oxygen.
Yeah. Let's use the word ratios. Let's use balanced chemical equations. Because conservation of mass requires balanced chemical equations. This is not balanced. What does balance mean? Think of a scale. Which side has too many or not enough particles? Liam. Right, so tell me what, like, does this side have too many particles? Does this side have too many particles? Okay, so which side, so think of this as a big scale, right? So here's like our scale. Okay, over here we have H2 and O2, here's H2O. How are we tipping? It is what? Lighter or heavier? Look at the numbers. So right here is right here. This side's heavier, right? That's 34, that's 18, so we're cockeyed. It's not balanced. Balanced chemical equation. Who's heard that term before? You learned in biology, I know you did. Mr. Governor, I walked by the room and heard her talking about it. This side is not balanced with this side, so it's breaking the law of conservation of mass. Conservation of mass really is all about particles. How many H's are right here? 2. How many O's? 2. How many H's here? How many O's? 1. So we have 2 H's, we have 2 O's, we have 2 H's and 1 O. That's not balanced. I need the same number of particles on both sides. That's what mass is all about. It's the number of particles. What do we do? Can't. Oxygen comes as a pair. Has to be O2. You want to add 4? You want to add more H's here? Or over there? You said 4 H's. You want to add 2 more H's here? So you want to add... This is what you want to add? Whoops. Yes or no? Yes? Okay. Let's do that. So she wants to add a whole other molecule of H2. Okay? But now we have 4 H's, 2 O's, 2 H's, 1 O. So now we're even more screwed up. You're on the right track, Emily. I like that. I would do the same thing. You want to add more over here? You want to add 2 H's over here? You want to add 2? You want to add more water? Let's do that. Another Mickey Mouse head. Floating Mickey Mouse heads. Kind of funny and disturbing. All right. Now, are your H's balanced? Yeah. 1, 2, 3, 4 H's here. 1, 2, 3, 4 H's here. So if you do the math, here's a mass of 4. Here's a mass of 4, so your mass is conserved. Good job. What's not conserved? Wait, is oxygen conserved now? Yes, 2 O's and 2 O's. So now we have a mass of 4 grams, 32 grams, and now what would this all be here? 2, 4, 6, or sorry, 1, 2, 3, 4, 36 grams. Is 4 plus 32, 36? Yes, that's conservation of mass. This is what conservation of mass is all about, and these particles are represented by these big numbers in front called coefficients. So from now on, when we start talking about conservation of mass and balanced equations, this is what I'm referring to. I need 2 hydrogens for every 1 oxygen. That will create 2 waters. So when water is created in this world, this is basically how it's created. You can argue with me, but you never just have 1 H2 and 1 O2. It doesn't work. It's always a 2-to-1 ratio. Why does that make sense? It's 2-to-1 ratio with more hydrogen. Why does that make sense? Think of the formula for water. There's 2 hydrogens for every 1 oxygen. So if I have 2 oxygens, watch what happens. This one bonds with those 2. This one bonds with those 2. They react completely to make water. If you don't have a 2-to-1 ratio, it's not going to work. If you only have 1 and 1, I make 1 water molecule and I have half an oxygen molecule floating around. That doesn't exist. That can't happen. So balancing equations explains a lot. Okay? I know that's it. It explains a lot as far as the mass is conserved, the number of particles are conserved. Every reaction you ever see here, the chemicals do this on their own. They know the ratio. I know that sounds weird to explain it that way, like they have a mind. But they know the ratio, and they form naturally that way. Okay? So I just kind of taught you a whole lot of stuff, whether you realize it or not. Particle diagrams are where we're headed next week. Conservation, balancing equations is where we're headed. All right? But it all relates to conservation of mass. Okay? So in your notes, what I want you to write down are these little particle diagrams and label the numbers. 4 plus 32 equals 16, conservation of mass, and a balance. So write all this down. Don't put these numbers up here. So copy that down. I'm going to hand back your quiz just because I said I would, but there's no way I have time to go over it.